Hello, friends. Today we are going to see the performance analysis on regression techniques. So, in ML models, there are two classification. One is supervised and unsupervised. So, under supervised, we have again two types, that is classification and regression. And today we are going to see about in regression technique how we can do the performance analysis. Okay. So, in performance analysis of regression, so before going for this, we will see about the types of regression, right? So, first, what is this linear regression is all about? So, it makes the prediction for the continuous, real, or numerical variables. So, mainly it deals with the real numbers. So that is the time how we are going to predict by means of the linear regression, right? So here, for example, all the columns in the data set related to sales, salary, age, product price, etc., all which gives only the numerical variable. So normally we will do for the categorical value and also for the numerical value. So, but regression mainly we will concentrate on the numerical values only. So we can say this type of regression, we can call it as like a supervised technique, right? Okay, so now we will see what are the types of linear regression, right? So the first we can see it's like a simple linear regression. So normally what is this regression? You will have like independent okay, variable and also dependent variable. That means what? Different columns. As I told you, all the columns having only numerical values only will be taken for regression, right? So in which you will have independent variable and also dependent variable, right? So in simple linear regression, normally you will have like one independent variable and one dependent variable. So it mainly it used to predict the value of a numerical dependent variable. Okay, then such a linear regression we can call it as like a simple linear regression. See, in which we will have one column which is dependent on the another column. So we can say such thing we can say it as like a simple linear regression. For example, if you want to predict the price of a car, so based on its age, you can say that if you are using the card for a number of years, then automatically the price also will decrease, right? So this is how we are just having one column, how much it is okay related with the another column, right? So it depends on the other column. We can say that the price of the car which is dependent on the another column age. Likewise, I can tell the statement, right? Similarly, what is this multiple linear regression? So here, one or more, okay, columns, which is dependent on the another column. So we can say it as like if more than one independent variable is used to predict the value of a numerical dependent variable. See, for example, here we are not limited with one particular column, but we can say that how we are predicting the price of a car based on the age and also another column that is mileage. So here we are using more columns, okay, as an independent variable which depend on this particular column price of a car. Got it? So this is how we are just predict the value, right? So this is also which gives only the output in a numerical value, right? So that's why we can say these are the examples for linear regression, right? Okay. So in linear regression algorithm, which shows a linear relationship between the dependent. So we can say that dependent variable as y and one or more independent variable as x variable. So we can say such thing as linear regression, right? So if it is a single means only one independent, and if it is more means we can say it is a as we say it is a multiple linear regression. Okay. So since linear regression shows the linear relationship, which means it finds how the value of the dependent variable is changing according to the value of the independent variable. So depend upon the application, we can say it is not only dependent, but also we can say that one particular column increases, whether the another column is increases or decreases. That we are calculating. For example, sometimes if a person working as a salary is like consultancy, right? So that is the time we are not having any increment for him. Okay, so consolidated pay, if you are just providing to the consultant employee or some people who are working as temporary, so that is the time there will be no increment for them. They will have like a 6 months course of time they will work, and they will get some incentive or some amount. Okay, so stipend, but they will not have any increment at all. So we can say that any number of years he goes, and also the salary will be same. And sometimes if we are using the car for a long time, the cost will be reduced. And if the mileage of the car, if it increases a lot, automatically cost also will decrease. Got it? So we can say that one particular column increases, another is decreasing. Another example, one column which is even increasing, the another column remains the same. In some situation, both column, okay, so that is independent variable also increases and dependent variable also will be increasing. Got my point? This is how we can say, for example, the number of years a person works in a company, automatically we can say experience also will increases. Got it? So based upon that, if you want to calculate the experience, we can say experience also increases. So in this situation, we can say both are increases. Sometimes one increases and the other remains the same. And another thing is one increases, the other column which decreases. Okay, the numerical value will decreases. Got my point? So this is how we are going to see the relationship between the different variables. Right. So now we can see the example, some of the example like regression takes a group of random variables, okay, thought to be predicting y, and tries to find a mathematical relationship between them. So this relationship is typically in the form of a straight line. Normally, we will tell the regression line as like, okay, it's a straight line. The starting point, sometimes it may be 0, or it may be some 20, or it may be 2. So at the starting point, according to that, the slope of the regression line also varies. Okay, so that we are going to find out. And all these dots, we can call it as like a data points. Got my point? So data points, and this is the regression line. How we are actually drawing the regression line means based upon the data points which is scattered, okay, in the graph. So when it is scattered, the maximum number of data points which is very closer to the regression line, we will say it as like a regression line, right? So all the scattered points will be fixed, and finally we are making the predicted this slope line, okay, so that the distance between the data points, say for example, the distance, yeah, between the data points and the regression line should be minimal. So then that is the best regression line. That is how we are making it out. And here it is pointing from 0 onwards, and we can say this is the line of regression, and these are all the data points. And here you can see the maximum number of data points which hits the regression line, and many data points which is very closer to it. The distance between the data point and the line, we can say it as like a error rate. Okay, so that is called the error rate, and the error rate should be minimal, okay, for many data points. That is how we are going to calculate. Okay, so that is the, this is the actual data, and this is the predicted one. Okay, this line with, okay, the regression line, we can say that it is a predicted one. Okay, it's a predicted line. Okay, so that is how we are going to differentiate the data points and the regression. Okay, that is a linear regression, right? Okay. So now we know about the how we are going to find the line equation, right? So for example, y is a dependent variable, means we have constant and coefficient. Okay, so constant is b0 and b1. That is, we will call it as like slope, right? That is also called as coefficient into x1. So x1 is like each and every data points on the x column. Okay, and y is a dependent variable, and this is x is the independent variable. Okay, so let us will see with the example. It is a line equation, right? Y equal to mx plus c. Likewise, you have learned in mathematics, right? For the line equation, the same thing we are going to put, and we have the formula to find the constant and the coefficient. How to do that? We will see one after another. Okay. So before that, we will say about the types of correlation. Positive correlation means, as I told you, one it increases, another also will increase. Okay, so that is positive correlation. Negative correlation, as I told you, one is increases, okay, and then the other is decreases. Okay, along the x-axis it is decreases, but along the y-axis it is increases. So such thing we can say it as like a negative correlation. As I told you about the price of a car and the number of months we are using. So depend upon the number of years the car using, according to that, the price of the car will be decreasing. So we can say that is the negative correlation. But the number of years a person working in a company, according to that, his salary also is increasing, his experience also increasing. All these things we can say that it is a positive correlation between the experience and the number of years the person works, or okay, salary and the number of years employee works. When we just make okay between the x-axis and the y-axis, the correlation we can say that is the positive correlation. As I told you, this is there is no correlation at all. Along the y-axis, it is increasing, but in the x-axis, the value remains the same. Got my point? So such thing we can say it as like correlation. No correlation. As I told you, consolidated pay, a person working, okay, temporarily in a company. So that is the time that will be no increment at all. Even he is working for 4 years or 5 years, a project, but the salary, it's not going to increase, okay, because he's getting only consolidated pay. Okay, so that we can say an example for no correlation, right? So that is how we are just seeing the relationship between the variables, right? And finding the best fit line. How we are finding the best fit line? As I told you, between the predicted value, that is the line, slanting line, okay, and the actual value, that is the data points. So the best fit line, how we are going to calculate is the difference, okay, between the error between the predicted value and the actual value should be minimized. Okay, so that we can say it as like a best fit line, or otherwise we'll have the least error. Okay, so the different values for weights or the coefficient of lines, we can call it as like a naught and a1. As I told you, a naught, okay, we have seen already, right, in the line diagram, right? So we can say that is constant and coefficient, that is a1. Got it? So that is how I can just find out the value of this a0 and a1. Okay, the different values for the weight for the coefficient of lines a0 and a1 gives a different line of regression. So we need to calculate the best values for a0 and a1 to find the best fit line. So to calculate this, we use the cost function, right? So how to do it? Okay, see for example here, between the salary and experience, as I told you, both are increases. So we can say that is the positive, and then salary and experience. We are taking from the zeroth level. So we can say the slope which starts from the zeroth position in the x-axis. Okay. And here we can see that from the rapid growth, okay, we are drawing the graph. And we can say all these data points which is closer, okay, which is closer to the slanting line. Okay, so that we have to find out. Okay, so we can say it as like y equal to c plus b into x. Okay, for the this example, you can say that y cap and y. Okay, simply y. Y is the, as I told you, it is the actual data point value, and y cap is, we can say it as like a predicted. Why we are using y1 and y1 cap means, as y has many values. Okay, so each and every value I starting from 1 to n. Okay, so according to that we are going to put for this. Okay, and then how we are finding the error also. Okay, we can say that y, okay, and into y1 bar, or yi bar. Okay, so that is how we are finding the sum of the squared. Okay, sum of the squared error. Okay, so that is how we are going to find out, that is y minus y bar the whole square, and sigma, which ranges from I equal to 0 to n. Okay, so sample data set, if you look at it, you can see that once the experience increases, the salary also increases. So we can say this is the positive correlation. So year of experience, salary is like this. 1.3 means it reaches to 45. 1.5 again. Okay, so it decreases. Some situation, if a person can getting the consolidated pay, that is the time there will not be any growth for him. Only a person, okay, so who did, okay, so for such people only who is active, only we can see based upon the experience, the salary also increases. So this is how we can find the correlation between the two sample columns. Okay, and see here, when we see the linear regression, you can see for this line, okay, so line algorithm, we can see that y equal to b0 plus b1 into x. So in which b0 we can call it as like a constant, and b1 we can call it as like a slope. Okay, so we have to substitute the value of B1 as a different value, and we are getting the answer to it. Okay. So in this, you can see an example. It starts from 0. So we can say the experience is 0 for an employee. So that is the time he is getting 30K. Okay. So it is reaching up to 1 year. After that, okay, we are just find the hike in salary. Okay, so that is the time what we are going to calculate. That is the time for additional 1 year. Okay, so after 3 years, additional 1 year, if a person works, we are giving 10K as an intensive. Okay, incentive. So incentive, if you are just adding, okay, along with the salary. Okay, so 1 year, for 1 year we are just calculating, okay, based upon the value, we can say that additional to 30K, we can say 30K, okay, 10K. Okay, so this is the constant, and this is like a slope. Okay, that is b1. Okay, so if the experience is 0 means automatically this parameter also will become 0, and we will get the value of only b0. Got it? So that's why it starts from 30K. So once the experience increases by 1 year, so automatically b1 value also will change, and according to that, that will be added with the initial value of 30K. So we are getting 40K for 1 more year if a person works additional experience. Got it? So this is how we are just drawing in the linear regression to find the real answer. Okay, so in this, we can see that y minus y cap, that is y predicate. Okay, so what we are just predicating, that we can call it as like a y cap. How to calculate the y cap? I will just show you in the coming slides. And y is the each and every value of y column. Okay, so we are just subtracting to it, and we are just calculating it, which is the minimal. We can see that y, and then predicted y predicts, okay, that is y cap, and then these are all the values. Okay, so we can say that which are all the values which is very less. Okay, so that is the error rate which is lesser. We can consider that data point as the right data point. Got my point? Okay. So that is how we are just drawing the thing and finding the minimal value of y minus y cap the whole square. Okay. So that will give you the right answer, right? And then we are going for regression line. As I told you, y equal to a naught plus a1 into x. How we are calculating this a1? Okay. So we can call it as like this a1 as the slope and a0 as an intercept. Okay, so how to calculate that? So for that, what we have to do is just we are finding the x minus x bar. So we have two columns. One is x, another one is y. We are finding the mean for the x value, mean for the y. Okay, and we are getting y bar. Okay, so divided by x minus x bar the whole square. Okay, just substituting this value, I will get the answer for a1. That is this slope. Okay, so after getting the slope, okay, what we are going to do is we are just finding the value of the intercept. Okay, that is a naught. A naught which is equal to y bar minus a1 into x bar. Okay, so y naught in y bar minus a1 into x bar, right? Okay, so that is how it is. We are calculating for a0. Okay, so how we can write for the code? So when we are just giving it as like x mean, okay, so that is np dot mean of x. Okay, so that means for x I'm finding the mean, and then for y I'm finding the mean of it. Okay, and then I'm just printing the x mean and y mean. I'm getting the value for it, and the mean for years experience is this one, and salary, that is for the another column. Okay, I'm getting for x and y. This is how I'm getting the value for this x bar and y bar. After that, each and every x value we have to subtract with the mean, and each and every y value with the mean. Okay, y mean. And then we are going to find the x minus x bar the whole square. Okay, so that we are keeping it as a denominator. How we are going to calculate for a1, that is slope, okay, numerator, and denominator we are going to write separately. Just look at here, you can see here as like, okay, so just sum of, okay, we can see like sum of this one, okay, summation, and that is xi, that is xi is the each and every x value minus mean of x, and then yi minus mean of y, okay, and divided by summation of xi, okay, minus mean of x the whole square. Got my point? Just we are writing as it is in the equation, right? So this is how we will give it in the code. And then a naught, how we are calculating is mean of y, okay, so that is y bar minus a1 into mean of x, that is x bar. Okay, so that is how I'm just calculating the a naught. Without calculating a1, I cannot substitute in a0. That's why first we have to calculate a1 followed by a naught. There we are getting the value of a1. Just substitute here, and this is simply right. Already we have mean of y, that is y bar, and that is mean of x, that is x bar. Already I have the value here. Just I am substituting here after finding the value of a1. Right. So this is how I can calculate the intercept and the slope. Okay, using the Python code. Okay, so now we can say that this is the predicted value, and all these data points we can call it as like a, okay, so actual value. Okay, so that is how we are just differentiating the predicted and the actual value, right? So how we can give print of intercept. Okay, so already we found the float of a0. Okay, so a0 already we found. Okay, so that is a0 here. Okay, and then a1 already we found. Okay, so just we can print the value of intercept is a0 and slope as a1. Okay, I'm just printing it out. Okay, so I'm getting intercept is, this is the value, and the slope is this one value. Okay, this one I'm getting it out. Okay, so and then I have to go for each and every predicted value, right? So then only I can draw this line. Okay, so for that, what I have to give. So as I know, as you know, this that is the y cap. So say how to give the y cap, that is y predicts, which is equal to a0. A0 we know that is an intercept and a1 is the slope. Okay, so that is how we are just calculating for the predicted value for all the y values. We are finding this thing. Okay, so that is how I'm getting the predicted value as well, right? Okay, so this is an example. Okay, so when you look at it, easily you will understand these are the x values which is will be stored in the array format and y will be an array format, and then just finding the mean value of x and the mean value of y, that is y bar. Okay, and finding the x minus x bar and the x minus x bar the whole square. Similarly, y minus y bar, that is the mean value, and then we are finding it out x minus x bar into y minus y bar. Okay, and then we are finding the predicted. Okay, so that is as we saw in the previous one, a naught plus a1 into x, and already we know how to calculate a1 and a naught. Okay, so after substituting the value of a naught and a1 in the line equation, I will get the predicted value y predicts. Okay, so that is minus 9.6, 15.7, likewise I'm getting the predicted value for each and every x and y values, right? Okay, so and now I'm finding out the error. Okay, so error, how I'm calculating is y predicts minus y the whole square. Okay, so that is how I'm just finding the thing. Okay, so that is y predict minus y. Okay, the whole square. When I'm just finding out, I can see that error. Okay, so error rate should be minimal. Okay, so according to that, I have to draw the predicted line. Okay, and predicted line and then actual data. Okay, so we have to compare with that and subtract to it, and that value should be minimal. Okay, then only I can say that is the best fit line. Okay, best fit line, right? Okay, so this is how I'm just calculating. Okay, so and then so till now we have just to find out the predicted line. Okay, but we are not talked about the performance evaluation. But in the question, we have seen that for the linear regression, we are finding the performance evaluation. Evaluation. Okay, so performance evaluation, there are three formulas we are going to find out. First one is R squared method, and the another one is mean square error and root mean squared error. Okay, and then the mean absolute error. Likewise, I have to calculate this. Okay, first R squared method, how to calculate. Okay, we will have it as like SSR by SST. Okay, so that means what? How we are calculating here, sum of squared errors in which I am getting the actual data, that is the data point, and the predicted data, that is the best line fit line. Okay, so the whole square. Okay, when I make the summation of it, I will get the SSR, and the SST is sum of the squares of summation of y actual minus y mean. Okay, so here I am using the y bar, and here I am using y cap. Got my point? Okay, when I'm just subtracting with the y cap, okay, I'm getting the value of SSR, and SST I'm getting from y mean. Okay, y bar the whole square. When I'm just making it as like 1 minus SSR, this value by SST, I will get the R squared. Okay, so that is how I'm just calculating it. And then what is this mean square error? So here I'm just having y minus y cap. I can put either like this or y cap minus y. Doesn't matter. Both are same only because we are making the square of it. Even if it comes with a negative value also, no problem. I'm just making the square of it. I will get the answer. Okay. So that is how I'm just doing for it. And then n is the total number of data points. Okay. So divided by the total number of data points, I will get the mean square error. Okay. And coming to the root mean squared error. So just small difference here. Okay, sigma of I equal to 1 to n. Here also I am giving y cap minus y I, or otherwise yi minus y cap. No problem, because I'm going to make the square of it. Okay. So here the thing is by n also it will come. That is the total number of data points. But the root I have to take. So that's why we can say this is root mean squared error. Okay. And coming to the next, that is mean absolute error. Here also y minus y cap or y cap minus y, doesn't matter. We can put an absolute value. So it will give only the positive value of it. Okay, positive value of it divided by n. Okay, so again we have no square or we have no square root. Here only we have only absolute value. That is mean absolute error. Okay, so that is the another way we are finding the performance. Okay, for the linear. So this is how I'm just using r square. Okay, and then okay, MSE, RMSE or MAE. Okay, so this is how I'm using these three parameter. Okay, so for calculating the performance in the linear regression. Okay, so in the next video, we will see about how we can use the Python code. Okay, and do it. Okay, so that you will get the clear picture over it. Okay, so